Even with all its flaws and imperfections, I simply love the observer design pattern. But let me explain. I still remember when I first learned about it in my design patterns lectures a long time ago. Before that, I had certainly encountered it, but I didn't really understand the greater scheme behind. I guess at that point it was probably just one of the many things that you could do with inheritance and object-oriented programming. In this video, I will briefly show how to add it manually to any project. I will also touch on the advantages and disadvantages of this somewhat infamous piece of software engineering history. Please note that the observer pattern is still widespread, and it comes built in with some languages and frameworks including C#, Java and others. As a result, in most cases there's no need to completely reinvent the wheel. Now let's talk a bit about the traffic light simulation that I cobbled together in Unity for demonstration purposes. So the other day I was walking around with my design patterns Bible as usual, and I stopped at a red light. I then thought to myself, what pattern could be applied to this situation? In my mind, the traffic light immediately became the subject, which has some information to share, and the cars transformed into observers consuming the traffic light status changes. Putting this in a class diagram, it should look somewhat like this. So how does this work? When we start the simulation, the subject or traffic light has an empty collection, such as a list, of observer cars. Every time a car registers, it is being added to this collection, which is printed out in the upper right corner to make things a bit clearer. Each time the traffic light color changes, all observers in the collection are notified about the update and react accordingly. For any of this to work, the observers implement a generic observer interface which is supported by the subject. In other words, there must be a common way or some method to let the subject notify the observers when something changes. Furthermore, having this interface allows us to A. Put all registered observers in a single collection of the same interface type, and B. Iterate over all registered observers and update them at the same time. On the subject side, we implement an interface to easily register and unregister observers. Because once our cars drive past the traffic light, they no longer care about the subject and they don't want to receive any more updates. In a nutshell, the observer pattern allows you to work on your subjects and observers separately. Changes on either side won't affect the other side as long as the interfaces stay the same. Furthermore, it's an easy way to simulate basic publication and subscription or even event handling scenarios, but I let you research this by yourself. At this point, you might have noticed that some things may seem a bit off. Because looking at our simulation, it's not how things work in reality. Put differently, when was the last time you registered to a traffic light in order to receive light status change information? In fact, most traffic lights in the real world are not aware of your presence. You may ask why this is a problem. In a nutshell, systems are often built to closely mimic real life. In fact, this is at least partly the point behind object-oriented programming, even if people have become less obsessed with this idea in recent years. Of course, I'm not saying that such a scenario could not happen in the future with some fully connected and smart cars, but at least for now, it's definitely not how it works. And yes, there are some ways around this problem, but then again, you will stray away from the classical Gang of Four pattern for better or worse. For example, some implementations of the pattern end up with what is called tight coupling between the observers and subjects, even if the original pattern tries to mitigate this by using interfaces as abstractions. This coupling then means that both sides are highly aware of each other, which is quite often not a desirable trait in software engineering. The book also mentions different ways of providing updates and whether status information should be pulled from the subject or being pushed to the observer, which has different consequences on your architecture. As hinted before, there's some ways around parts of the inherent issues of the pattern, but I won't go into this rabbit hole in this video. If I made you curious, just Google it, and you will find lots of arguments for and against this system, and I encourage you to participate in these delightful discussions. As with my previous Abstract Factory 101 video, I forced a design pattern into a random scenario, which is always a great idea. All joking aside, there are better ways if you want to build a simulation, but I thought it was kind of interesting to play around with it, at least for a while. In any case, I hope it showed you some of the beauty of this pattern and also made you think about some of the drawbacks. As usual, the code is linked in the description, and I thank you for watching.